Welcome to MLE Masters. In this session, we'll be covering one of the most high-yield and testable topics in genetics, inheritance patterns. Understanding these concepts is not just essential for Step 1, but also forms the basis of clinical diagnosis and pedigree interpretation. Genetic inheritance patterns explain how traits and diseases are passed across generations. In this video, we'll go over the major types: autosomal dominant, autosomal recessive, X-linked recessive, X-linked dominant, mitochondrial, and even the rare Y-linked pattern. This foundational knowledge is crucial to cracking pedigree-based questions and clinical scenarios on the USMLE. In autosomal dominant inheritance, a single mutant allele is enough to cause the disease. It affects both males and females equally and typically appears in every generation, a pattern we call vertical transmission. If one parent is affected, there's a 50% chance that each child will inherit the condition. Remember, unaffected individuals do not pass on the trait. Some of the most classic autosomal dominant disorders include Huntington disease, Marfan syndrome, familial hypercholesterolemia, neurofibromatosis types 1 and 2, hereditary spherocytosis, and achondroplasia. These are exam favorites, so make sure you can recognize both the condition and the inheritance pattern. Autosomal recessive conditions require 2 defective alleles, one from each parent, for disease expression. These disorders often skip generations and affect both sexes equally. They are more commonly seen in consanguineous relationships. Carriers are typically asymptomatic, which can make pedigree interpretation tricky. Look for a horizontal pattern: multiple affected siblings but unaffected parents. Examples of autosomal recessive disorders include cystic fibrosis, sickle cell anemia, both alpha and beta thalassemia, phenylketonuria or PKU, Tay-Sachs disease, and various glycogen storage diseases. Many of these are screened for in newborn testing, so keep them on your radar. X-linked recessive conditions primarily affect males, since they have only one X chromosome. There's no male-to-male transmission, and all daughters of affected males become carriers. This pattern often skips generations. On a pedigree, look for more affected males and a maternal transmission pattern. Key examples include hemophilia A and B, Duchenne and Becker muscular dystrophy, G6PD deficiency, Lesch-Nyhan syndrome, and Hunter syndrome. In many Step 1 scenarios, you'll see male children presenting with symptoms while their mothers are asymptomatic carriers. In X-linked dominant conditions, both males and females can be affected, but there's still no male-to-male transmission. All daughters of affected males are affected, while sons are spared. Females may show milder symptoms due to random X chromosome inactivation. These conditions tend to be more severe in males and often appear in every generation. Examples of X-linked dominant disorders include Rett syndrome, Fragile X syndrome, and hypophosphatemic rickets. Fragile X in particular is a high-yield favorite for USMLE questions, often presenting with intellectual disability and physical features like a long face and large ears. Mitochondrial inheritance is unique. It's passed only from mothers to all of their children, regardless of sex. This is because mitochondria and their DNA come entirely from the egg cell. These disorders usually affect organs that require high amounts of energy, like the brain, muscles, and eyes. Classic mitochondrial disorders include Leber hereditary optic neuropathy, Melle syndrome, Me-Arf syndrome, and Lee disease. These conditions can be challenging, but their inheritance pattern is a strong giveaway. Every child of an affected mother is affected, while none of the children of affected fathers are. Y-linked or holandric inheritance is extremely rare and affects only males. It's transmitted from father to son. And since females don't have a Y chromosome, they cannot be affected or transmit the condition. Examples include Y chromosome infertility and Swyer syndrome. When analyzing pedigrees, remember these clues. Vertical transmission suggests dominant inheritance. Skipped generations point to recessive traits. More males affected suggest X-linked recessive. All daughters affected. Think X-linked dominant. And maternal-only transmission means mitochondrial. These clues can help you eliminate options quickly in USMLE questions. Thank you for watching this high-yield review on inheritance patterns. If you found this helpful, give it a like, share it with your friends, and don't forget to subscribe to MLE Masters for more USMLE prep videos posted daily.